So today is basically it's lesson 4. Okay. So perfect square trinomials are a special kind of trinomial. Okay, they're kind of nice. And we saw them. We manipulated equations in standard form when we were completing the square to ultimately produce perfect square trinomials. That's how completing the square worked, right? And I didn't bore you or try to complicate completing the square by showing you this process because I showed you the shortcut, right? But this is actually what's going on, right? So we have, you can always solve these using the decomposition / table method. Okay, the stuff I just showed you, right? You can always do that. But there's a shortcut to solving them as well. Okay, so I'll show you both. I'll show you both so you can see, right? And then I think the major thing that a lot of kids struggle with is just the recognition of the kinds of trinomials or factoring types that are in front of them, right? It's 100% about being able to recognize a perfect square trinomial as a perfect square trinomial relative to just a regular complex one, right? Versus like a difference of squares, which we'll do today, versus a simple trinomial versus something that you could pull a common factor out. Like that's like everybody gets confused on which one's which, right? So that's, you just do enough of them and you figure it out, right? So with these, it's always a trinomial, right? And the first and third terms, so the A and the C values combined with their variable, right, are always perfect squares. Right? And then the second term, so the B, whatever's attached to the B with the variable, right, has to be even so that you can cut it in half. Okay? And then the middle term of this is equal to the expression 2A times C. Okay? Which just looks like a jumble. It doesn't really mean anything until I actually put one in there, then it'll make sense. Right? So it's 2 times the square root of A times C. Okay? So I'm going to go down here for a sec. I suppose we could make note, somebody's got a note here, it says if all of these aren't true, then it's not a perfect square. Okay? Yeah, Ian? Yeah, here, I'll write that later. I was worried about that. So it's AC, it's A times C square rooted multiplied by 2. That'd be like the order you do it, right? So I could check that. We can check that, okay? We'll do a couple questions here. So if I check it with A, I can check it with A right here, right? So 2 times, what's the A value? 49. 49 times 1 is 49. Right? The square root of 49 is 7. Which is equal to 14. So that tells me that the B value, there's the 14. So I know it checks that, right? We're good. Right? So I'll do this 2 ways. You're not going to want to do it the one way, right? You're going to want to do it the shortcut. So again, this is about identification of each of these methods and applying them in the right situations to save yourself time. That's all this is about, right? Okay, it's about recognition. So let's go I'm going to solve this in a regular, just complex trinomial method like we did yesterday. Okay? So I'm going to need two numbers to multiply to what? 49 times 1, right? So I need two numbers to multiply to 49. Add to what? The middle term, right? 14. Yeah, no.
Just to clarify, if there's no like common factor, you multiply, but if there is, then like divide. Is that correct?
Yeah, you have to divide it to get the factor out.
Yeah. So
When you're dividing it, does it always have to be by 2, or does it have to be by whatever
Whatever you see in common. So if I had like
7 in common?
no.
7 can't go into the 1 though.
Oh, it has to go in all.
It has to go in all 3 in order to take it out. Yeah, unless you're completing this. We did it where we didn't take it out of all 3 for completing the square, which is a different thing, right? So for a question like this, 5x squared plus 25x plus 10, I take a 5 out, right? So it'd be 5x squared plus 5x plus 2, right? So it just depends on what's there, right? So this one, I can't take anything out, right? So I got to come up with the two numbers that satisfy the condition, right? So I can go 1 times 49, never going to add to 14. 2 doesn't go into 49. 3 go into 49. 36 and another. No.
This is a decimal.
Okay. 4 doesn't go into 49. 5 doesn't go into 49. 6 doesn't. 7. 7 times what gives me 49? 7. So the two numbers are the same. The two numbers that work here are 7 and 7. That's a special circumstance. That only happens for perfect square trinomials. Right? So you can choose to do it this way, which is fine. So I'm just going to do the same. I'm going to do the table method now, right? Because I like the table method. And because I don't see any issues with having a plus and a plus here. I know the table's going to be fine, right? So I'm just going to draw a table. I'm going to go, okay. I'm going to get 49x squared. I got to move this table down a sec. And 1. And I'm going to fill in the 7x and the 7x. Okay, I'm going to fill in the length and width. So I'm going to start reading off stuff from top to bottom and left to right, or right to left, right? So top to bottom, from here to here, what's in common? Well, I'm seeing, okay, I can take out 7 for sure, and then I can take out the x, right? And then I keep going. I'm like, okay, well, I can only take out a 1 here. And then I go the other way. I'm like, okay, I could take out a 7 here and an x, and same thing, I can only take out a 1, right? And then I go back and fill in the signs. Okay, well, it's plus 1 and it's plus 1. And then when I write out the length and width, I get 7x plus 1 multiplied by 7x plus 1. Well, I get the same thing twice. It's a perfect square. Why is it a perfect square? If I drew this here, this is why it's called a perfect square, by the way. If you were to draw a square, give me dimensions of a square. Seems like a stupid question, but give me a square. What would a square look like? If I drew one. It's a square. What about the side lengths? What's specifically about the side lengths makes it a square versus a rectangle? They're equal. 4 and 4. Or you could have 42 and 42 or 421. You know what I mean? It's a square because the side lengths are the same. Well, I just drew a rectangle up here, didn't I? Right here. Right? What were the side lengths? 7x plus 1 times 7x plus 1. That's why it's called a perfect square. Because the two side lengths are the same. Yeah, you two. You got the same question?
Yeah, bro. Would you make make it a bracket and then put the square on there?
Yes.
Yeah.
Okay, so there's one more step to this. Because I have two of the same thing, I can go like this. 7x plus 1 squared. That's your final answer. Both of these are correct. I'd accept both those. Okay. Now, I'm going to show you the shortcut, and you're going to go, I'm going to do the shortcut every single time because I want to save myself time. Right? As nice as the table is, there's a faster way. And I love the faster way. Okay? So, I'm going to try and clean this up here so it looks nicer. Okay? I see here, here's two things going on. What did I say? What did I write up top? It's always a trinomial. It's a trinomial. First and third terms are perfect squares. What does that mean? It means that if I can square root them, they're perfect squares. So if I can put a square root over top of it and get a nice number out, it's a perfect square. Yeah, Ian.
That has to be for both of them?
Has to be for both in order for this to work. Okay? Because these are all conditions. Remember I said here, if all of these are not true, then it's not a perfect square. So you have to have both of them for perfect squares. Okay? So I'm going to go down here for a sec. I look at, what is the square root of 49x squared, Aiden?
7x squared.
You squared the x squared, though. What's the square root of x squared?
Oh yeah, this square will be gone, so it'll be 7x.
7x. So I'm going to take the square root of the first term. That's going to be 7x. What's the square root of the last term? So square root 1. How many of them are there? Oh, I didn't. One more thing, sorry. You don't know if it's a plus yet. Is it a plus or minus? It goes in the middle. How do you know it's a plus? Because I wrote it on there?
Yeah.
The plus comes from whatever sign's in the middle. It's just a rule. Square root the first, square root the last, take the sign from the middle. So in this case, it's a plus, and then I know because it's a perfect square, I have to have a length and width that has to be squared. That's your shortcut. I would not do this with the table, ever. If I can recognize these things as being perfect square trinomials, I'm never going to do it with the table. That took me 2 seconds.
So that would be the first option to check if they're both square, and if they don't, then do the table.
Then do the table. So if they don't, so by that, Aiden, so if you check, if any of these things here are not true, you can't do this. Right? So you're just check them, right? If it doesn't work, then you just do the stuff that we did yesterday with the complex trinomials.
How would I show my roots for that?
That's all you got to do. Just draw over top. I would just draw whatever I have in blue would be enough work for me to see what you're doing. Right? The two square roots, and then circle the sign or something. Right in the middle. Ultimately, again, it comes down to I'm going to ask you to do questions, word problems, and I don't care how you get to the answer, but I want to see some stuff, right? These are just processes to help you. Yeah. Yeah. Okay. You ready for this? What's the next one? You guys ready?
Yes.
Okay. How do I do this one? Square root of 9x squared. Square root of 16. 4. What goes in the middle?
Negative.
Because it came from the b, right? How many of them are there?
2. Wait, what do you mean how many is there?
Square.
got to have a length and width, right, in order for this to work.
Sorry, twice that.
It's got for this exact same reason.
So basically, if it, like the square root worked, then it's always gonna have.
Yeah, you're gonna have two of them. This is basically the way the square root works. Is like square roots break things into two equal pieces, basically, right? That you can multiply together. So you got to have the squared there in order for that to work. Right? Well, that was easy. You okay, Julia?
Yes.
Oh. So you just got to look at it. You're like, okay, there's certain things I would check. I would check. This one's dead easy. I might even put this before common factoring. Right? I would look at that and go, okay, is it a perfect square? This would be the order I'd ask questions in. Is it a perfect square? The second one would be, is there a GCF? If not, then you're stuck. At all costs, I'm trying to avoid doing the table method and the complex trinomials. That's what I'm trying to avoid, right? You don't want to have to do that. That's a last resort, working with the complex trinomials. So if there's a way to avoid doing that, these are the first two that I would check. You want to do the next one? Okay. Same thing. Let's look at this one. This relies on you knowing your multiplication table, and that specifically that the main diagonal of it, right? So the 2 and 2 is 4, 3 and 3 is 9, 4 and 4 is 16, 5 5 25. It's just recognition, right? It's recognition of that main diagonal. Right? So you're like, okay, well, let's look at this one. Square root the first, square root the last. What do I get? 6x. That comes from here. Plus, sorry, it's 1 over here. That comes from here because the square root of 1. And then I take the sign from b. And there's two of them. And if you don't believe me, you can do this. Remember what we said? We can always do this to check. Right? 6x minus 1. 6x minus 1. Fill in the inside. 36x squared minus 6x minus 6x plus 1. 6x minus 6x is going to give me the negative 12, and there's my trinomial back. It's very difficult for me to lie to you because we can always just check stuff, right? It's very easy to catch if we've done something wrong, if you know how to check, right? The nice thing about the table and the area method is like length and width go hand in hand with area, right? So always check that. Okay? Guys good? That's it, like today's lesson's like, it's refreshing to see something like this because it's a little bit easier, right? Okay? So that's perfect square trinomials. Okay? That's where we get two pieces that are the same when we create a square, much like it was 4 times 4, right? I find that by square rooting the first, square rooting the last, taking the sign from the middle term. Okay? The last type of factoring that we're going to do is what's this called? Like difference of squares. Do we see a relationship between the name of this and what we see on the page? It's a difference, right? What's the word difference mean? Yes. Give me a math. So if I had to pick an order of operation mathematically, what would you put with the word difference? So you got like product. Product would be multiplication. Quotient would be division. Sum would be addition. And difference would be subtraction. Difference between two numbers, so that's subtraction, right? So I see on my page, I see a difference, a subtraction of two squares. Right? This is like identically easy, I would say. I'm not even going to show you anything else. I'm just going to show you the method because it's a waste of time to do it any other way. So if you see two terms like this, and they're separated with a negative in the middle, it's a difference of squares, and this is what you have to do. It's identical, right? Okay, so I'm going to go, okay, same thing. I'm going to square root the first, and I'm going to square root the last, right? So what's the square root of, yes, 4 what? 4x, yeah. And then, yeah, minus 5. But here's the problem now, okay? I can't throw the squared on there because it's not a perfect square trinomial. The two pieces are not going to be equal this time. For the reason, if I do this, if I draw the table out, right, I need it to come out to be minus 25, right, Aiden? Right, I don't care about the top and bottom pieces, the left and right. Okay, what do I need to be right here? Sorry, this is supposed to be 25. What has to go right here on this we'll call it the width, in order to make this table work out? What has to go right here? So I'm multiplying this by this to give me this. Do you guys know? What has to go here? No, 5 times 0 would be 0. What do I have to put right here so that when I multiply this by this, it gives me this? Positive 5. Right? So this only works. Right? This is not a perfect square trinomial because the length and width are not the same, right? So the only way for this to work now is if I have a positive 5 in the second spot. That's difference of squares. Almost identical to a perfect square trinomial, except this. They're opposite signs. So now we can just rip through these kinds of factorings, right? So I can go, okay, let's do the next one. Who wants to do the next one? You want to see another one? I'll do another one. Okay, so square root of 9x squared. What is that? I'm dealing right here. 3x. And then the square root of 36. 6. I'm going to throw a negative sign on 1, and I'm going to write it again. 3x plus 6. That's it. I promise you that expands out to give you what you got back.
So why is one negative and one's positive?
For this reason right here. I need a negative in this bottom corner. If this one was negative as well, right, Noah? Then I get positive 25, because this times that is positive 25 if it was negative. But I need it to be negative in the bottom right. Okay? These ones are, well, okay, so they start getting a little bit more complicated here. Okay, I'm just kicking it up a notch, but the process is the exact same. Okay? You ready? These get interesting. I like these. Okay? Same thing. Difference of two squares, except this time I got x to the power 4. It's a little more complicated. What am I going to do there? Good. What happens if you square root x to the power 4? Did everybody catch that? That's how the exponents work, right? We'll do exponents later, right? So this is going to turn into 4x squared. Then what? Square root of 1 is 1.
Yeah. So then
Right?
it should be -1.
And I'm going to write it twice, 4x squared 1. One's going to be negative and one's going to be positive. Now, are these not difference of squares in themselves? So we do it again. Square root the first, square root the last. Square root the first, square root the last.
What if you can't square root like something like 49 is the first number, then you square root it?
And you stop. You stop.
Like if the first number instead of 16 is 49, and you square root 49 makes 7. You can't square root 7. You just can't. You can't. Yeah.
Yeah, you go until you can't go anymore.
Okay.
Right? That's like the overarching, like, that's factoring. Go until you can't go anymore.
So with 100, you're gonna have to go like.
100 will go to, we'll do that one. That's like, that's E, right? We'll do E in a second. Okay? So this one, this is going to turn out, what's the square root of 4x squared? 2x. Square root of 1. You want me to do that? Here, you want to see? Look. So the way this works is, if I square root this, I'm basically taking square root of 4 multiplied the square root of x squared. What is that? What's the square root of 4? 2. What's the square root of x squared? X. Just combining the two. You just do it in one step. What's the square root of 1? Okay. So I get 2x, 1, but remember with difference of squares, I have to have two pieces when I do this. So it's 2x, 1. One has to be negative, one has to be positive. And then I do it again. Now there's one more way to simplify this. I have 2 at 2x minus 1s, and I have 2x plus 1s. So then I can write them like this. We'll be done. There you go. Everybody okay? You want me to do D, or you guys like?
No.
Okay. Want me to do E? I'll do E.
Let me try E first.
Try E first. If you want to try E first, yeah. Yeah.
So this one square root.
Okay, with D you're gonna get like 8 factors, right? You're gonna keep going and going and going until you can't. You just gonna keep like each one of these is like a square root. Square root. You're gonna get 8 of them. All right. Keep going and going. Square root the first, square root the last, and then have opposite signs. So you're gonna keep going. Just gonna have a list of 8 of them. Which is a little bit tricky. Keep track. Keep them count. Okay. I'll do E, and then I'll let you guys loose. Okay. You already have the homework for it. Okay. Okay, what'd you guys get for E?
10 squared bracket 10 squared minus 5, and then end bracket, and then bracket 10 squared plus 5.
I'm gonna write that down. What's that? What's that? Tell me. Say that again, Aiden.
So bracket 10 squared minus 5.
10 squared minus 5.
10 squared or x, right? 10x squared minus 5. And then bracket, that gets in a bracket, and then another bracket, 10x squared plus 5.
Is there anything else you're forgetting? I'm just looking at your answer. I'm going to say, okay, I see a 5 here, and I see I can take a 5 out. I collectively divide everything by 5, right? So I go, okay, I'm going to take the 5 out, and I'm going to get x squared minus 1.
Wouldn't it be 2 though?
5 divided by
Sorry, yeah, 2.
2x squared minus 1.
and the other one would be
Same thing with 5.
But then I can multiply this by this, right? Because this is a statement of pure multiplication. I'll do this question in a sec, okay? I'm asking about his answer to see if he did it, because he did it a different way. Okay, and then we'll see if we get the same answer. So it's pure multiplication. So I see a 5 sitting here, and I see a 5 sitting here. So I can go 25. All right? So I just took your answer and I made it a little bit simpler, right, by factoring out some stuff. Now you're going to see what happens if I do mine. We'll have to see here. What did I say to do always first? Always, what do you do first?
See if we can go lower.
I would say, right from the get-go, I would have taken 25 out.
With the minus 5 up front.
Sorry. I'm not having a good day today.
with minus. Oh, you just have to keep the minus, right?
Yeah, because if I put this back in, I gotta get the original back, right?
Right.
But I was able to do that because I took the 25 out. Now, I can square root the first, square root the last. Right? So this is me. I'll square root this one, square root that one. Right? And I'm like, okay, I'm gonna write square root of 4x4 is 2x squared minus 1, and then I'm going to have 2x squared plus 1. Okay? Then I'm like, okay, I can do it again. Oh no, I can't do it again, can I? Stuck. I think that's as far as you can go. But they match, don't they? Right? Not good? So then we know we're good, right? I did it 2 different ways. Your way's good too. Right? But it just goes to show, like, I think either of those two things are interchangeable. Remember I said this up here? I would always check to see if you can do 1 and 2 before doing anything else. Right? You can see how, like, maybe it's not imperative that you check for the greatest common factor before you check. You could even check difference of squares. You could say that's 3. You could check in all 3 of these, right? Can I do one of these 3 before I get to the complex? Right? Everybody good? It's got lots of questions there now, right? Get two pages of questions.